Okay, so in today's notes we're going to talk about angle pair relationships. So go ahead and get your name up there. And the name blank. Take ownership of it, and here we go. So the essential question today is, how can we apply the properties of angle pairs? Well, we need to know the angle pair words for we need to get comfortable with using the angle pair words. So there is something called complementary angles. Complementary angles is two positive angles that sum to 90 degrees. The way I remember complementary is that it starts off with a CO, and I can just make it look like 90 degrees, just like that. All right? So two angles that sum to 90 degrees. So we'll do this example on the left. It says that angle 1 is measuring 2x degrees and angle 2 is measuring 4x minus 6 degrees. All right? So if they are complementary, then that means that they add up to 90 degrees. There will be a formula on the wall that you'll find that says complementary somewhere up there. All right, over there in the orange poster, you see it? The word complementary. So this is our formula that we're going to be using. One of these angles is 2x. One of these angles is 4x minus 6. All right, and they add up to 90. Now, if I have a plus sign before a parentheses, then the parentheses can just fade away. There's nothing to distribute through. Plus, if you distribute a 1, then nothing changes anyways. 2x plus 4x is 6x. So that, I'm just adding like terms in that step. And then I have two more steps to do, and I think that you guys are brilliant enough to do those next two steps. So I want you to add 6 to get rid of that one, and then divide by 6. And that'll give you your final answer. So when you add 6, it'll be 96. 96 over 3. I'm sorry, 96 over 6. 16, I'm thinking. So let's put 16 in there as the answer for x. But this doesn't say what is x. The next blank says what is angle 1. Well, if you know that angle 1 is 2 times x, then how much does angle 1 have to be? Well, 2 times 16, right? And 2 times 16 makes 32. So that angle is 32 degrees. Then we're going to go and look at angle 2. Angle 2 says that it's 4 times x minus 6. But since we already know what x is, it's 4 times 16 minus 6. 58, you said? Maybe so. 4 times 10 is 40, plus another 24. So 54. 54 minus 6 is 48. Uh-oh, did I do something wrong? 40 plus 24. Yes, I did. 40 and 24 makes 64. 64 minus 6 is 58 degrees. All right, so what is awesome about those two numbers? When you add those two numbers, what do you get? 90. And what's the definition of what's the definition of two angles that add up to 90? No, that word is complementary. Very good. Now, why do they add up to 90? I'm going to tell you that. This equation right here forced them to add up to 90. So if you write your equation wrong, then you can potentially do all your math right, but your equation was wrong, so everything's wrong. You get what I'm saying? So, for example, what if I set the angles equal to each other? Well, if I set them equal to each other, then I would get a value for x, and when I plugged it back in, these two numbers they'd be equal. Okay, so it all depends on your setup. Your setup has to match up with the word. You get what I mean? All right. So let's just do the setup on number 2 so that we can move forward. So if these two are complementary, that means that they should add up to 90 degrees. So we're going to be using this formula. So what is the setup for this one? 7r plus 5 degrees plus 8r plus 10 degrees, right? It won't take too long to kind of get the rest of this in, so you know what, let's take a look at this. These have parentheses around them, but they're all positive numbers, so there's no negatives I need to worry about. There's no coefficient other than 1, so nothing really changes. Now here is the issue that I see a lot of people make when they are uncomfortable solving algebraic equations. The equal sign is way over here. Okay? If you can draw a box and not cross that equal sign, that means that it's all on the same side of the equal sign. If it's all at the same, like what I kind of look at is that these are two lunch tables. If they're at the same lunch table together, don't try to cancel any of them out. So don't like subtract 7r from 8r. Don't do that. They're at the same lunch table. All they need to do is just sit together. If they sat closer together, you would have 7r plus 8r, wouldn't you? So how many r's would you have? So 15 r's. So 15r plus, and now I have the constants, 5 and 10. That's going to make 15. So 15r plus 15 is 90. And then go ahead and drop down and write your answer. Well, let's see, I have 90. I need to get rid of 15, and I need to get rid of the other 15. So what are my two steps? Subtract 15, and then divide by 15. All right? So when you subtract 15 and divide by 15, what is that? 7? Thanks. So I'm going to take that 7, put it in for each angle, and hopefully the sum of those is 90 degrees. That'll be on your time though, okay? Let's go on down to the next vocabulary word. The next vocabulary word says supplementary angles. All right? Different than complementary. Different setup. Okay? Correction, r equals 5. All right, so what'd you get when you did 90 minus 15? 75? And 75 divided by 15. That sounds right. 15 times 4 is 60, so 15 times 5. That'll be that 75 that you're looking for. Yep, thank you. So there we go. All right, thanks. All right, so supplementary angles. Two positive angles that add up to, or that sum to 180. So the way I remember the word supplementary is I write the letters SU, and I kind of put a number 1 in front of them and make it S, and it kind of looks like 180, right? So supplementary, it kind of already looks like the word, or the numbers that it represents. So supplementary add up to 180. Complementary again, folks, adds up to 90. Okay, so here are two supplementary angles. The reason I know that those are supplementary angles is because if I were to put a protractor on this thing, And a protractor always measures 180 degrees exactly. So that's always going to measure 180 degrees. So these are supplementary. So the formula for supplementary we should be able to find that on a poster somewhere, although I'm not immediately seeing it, so maybe I need to add it. But it's angle plus angle equals 180 degrees. Okay? And I wish these numbers were a little bit easier. So you know what? Just to make this not so scary to look at as a first-time learner, let's call this 50. 184 is divisible by 2, so let's just call this 2. All right. Maybe this problem will look a little bit nicer now. Okay, so I have two angles. I need to add them together. I have 2q minus 46 plus 50 equals 180. Okay. Now, are the 46 and the 50 on the same side of the lunchroom? Are they on the same table? Yeah, if they're at the same table, then you do exactly what the symbol in front of them tells you to do. So what does the symbol in front tell it to do? That's a negative number. That's a positive number. You got to subtract. Yep. So 2q plus 4 equals 180. 180 minus 4 is 176. And q is equal to, it looks like 88, 82, maybe 82. $88. Oh, snap. All right, so 2 goes into that 8 times. No, 2 goes into that 8 times with 1 remaining. 2 goes into 16 8 times. Yep. Thank you. Yeah, so if Q is 88, then how much is angle ABD? Well, ABD was 2 times Q minus 46. Well, if it was 2 times 88 minus 46. You know what? That's some big numbers to mess with, but I already know that this angle's 50 degrees. So there's actually a quicker way to do that one too. So 2 times 88, 2 times 88, 176, right? All right, so 176 minus 46. Isn't that just 130? Now, what is awesome and fantastic about these two numbers? These two numbers add up to 180. Now, why do they add up to 180?
It's supplementary.
It is supplementary, but really the real reason is because you said that they add up to 180 in this top, right? If you didn't say that in that equation, then this messes up down here. So what you have to do is make sure that whenever you see the word supplementary, you start off with this formula. Okay? Okay. So there's a little bit of vocabulary down there at the bottom. It just says, given an angle whose measure is 30, what is the complement? Now, I know that that doesn't say what is the complementary angle, but there are some cases where you just kind of have to say, okay, well, it says complement. I don't know what it means, but I do know that complementary angle. I know that definition. Okay, so what do you think I mean when I say what is the complement? I'm saying what is the angle that is, or angle measure that is complementary. So For complementary, I would say 60 degrees, right?
Yes.
What about supplement? A supplement of 30.
150.
150. It's the complement of 100. There is no complement of 100. 100 is greater than 90, right? And it says it has to be a positive angle, so you can't say negative 10. But not a big, I'm not going to test you on that. Now, what's the supplement of 100? 80. Why? 100 plus 80 is 180. Okay, so today's lesson has so far been on complementary versus supplementary. All right, so there's something strange that is happening with these two problems up here. What's the difference between them? The one on the left, what would you call those angles? Versus the one on the right? And how about this one? What's the difference between this situation on the left and this situation on the right? So on the left, what's going on?
It's an obtuse angle.
Okay, yes, this is right and this is obtuse, but more than that. How many angles do you see here? How many angles do you see here?
2.
You should see 3 angles. Right? You see 2 angles and they're separate on the right side, but you see 2 angles and they share a side, and that makes a 3rd angle, right? So same thing down here. I have this one, they share a side, and this one they're separate. So if they share a side, there's actually a word for that, and that word is adjacent. Okay? So let's go down to this word right here, adjacent angles. Adjacent angles share a vertex and one side, but they do not share any interior points. So let's go through these options, A, B, C, D, E, and decide which ones are adjacent. Okay, so part A, are those 2 adjacent? If you're saying no, then you're right. Those are not adjacent. Why not? They don't share that point. That point needs to be down there, doesn't it? How about 3 and 4? Are they adjacent? Do they share a side? No, they don't share a side. In that case, they share a vertex, so that's good, but they don't share a side. Part C, what do you think? Do they share a side?
Yes.
Kind of looks like it maybe, but here are the 2 sides for angle 5. Here are the 2 sides for angle 6. Do they share a side? I don't think so. I see the black one, the black angle has 2 sides, and the red angle has 2 sides. They don't share a side. Right? Now, they do share a vertex. I agree with you there. They share a vertex, but they do not share a side. So this one, again, is going to have to be no, because they don't share a side in that one. All right, how about option D?
Yes.
Do they share a vertex and also share a side? Well, I'm going to do the same thing as I did last time, and I'm going to highlight that one in black, and then I'm going to highlight the other one in red. And you guys tell me, was there any overlap? Yes. Okay, this one is adjacent. Okay, so D is adjacent. That's the word for it. Adjacent means that they share a vertex, they share a side, and they don't share any common interior points. All right? It's a lot like a parking space. If I have an adjacent side to you in the parking lot, then that means that we share that little white line between us. All right? All right. Well, the reason that A isn't yes is because this angle's way up here.
But they still overlap.
They overlap, but this angle,
Could it be one?
no, it can't. It's not. They're technically, they don't share. They do share a side, but they don't share a vertex. That vertex for angle 2 is up here. The vertex for angle 1 is down here. They have to share a vertex and a side. All right, great question. All right, so how about part E? What? Scared to answer? That's okay. Do they share a vertex? And are they right next to each other? They share a side.
Yes.
Yeah, I agree with you. So yeah, this one had 2 right answers, adjacent, for that one. All right. Let me see. The next one, what we're going to do is define what a linear pair is. So we've got a lot of vocabulary today, right? We've talked complementary, supplementary. Now we've talked adjacent. Now I'm about to add linear pair. Yesterday it was angle bisector, right? So a lot of stuff going on. This is a vocabulary-rich class. So anyway, we have linear pair. It says that it's a pair of adjacent angles whose non-common sides are opposite rays. In other words, a linear pair looks like the letter Y. Okay, that is a linear pair. I'll put a little 1 and a 2 next to it, and then that way you know that you can see the 2 angles that add up to 180. So what must be true about the sum of 2 angles that form a linear pair? The sum, S, sum equals 180. Okay? So which one of these is a linear pair, the way it is drawn? Are 1 and 2 a linear pair? Yes. 3 and 4. The problem with 3 and 4 is that they don't add up to 180, right? So if they don't add up to 180, there's no way they can be a linear pair. So let's highlight 3 in one color and angle 4 in another color, and I'm going to ask you, does that fulfill the definition of linear pair? Linear pair says that they have to be adjacent. Are 3 and 4 adjacent?
No.
No. So this is not a linear pair. Angles 5 and 6. The way it's drawn is that it has this loop right here, and that loop tells you that angle 5 measures 180 degrees all by itself. Angle 5 then is this straight angle. If angle 5 is that straight angle, and angle 6 is just this red piece, then there are points from angle 5 inside of angle 6, and that's where that no common interior points thing comes in. Okay, so the main reason for giving you this example is so that you can start to see how we label angles. So sometimes we'll do a big arc like that, and that means that we have to go that whole way. Okay? So we'll finish up with one of these 2 examples. All right? So we're given a letter Y. It basically looks like a Y, and this is a linear pair. What do we know about all linear pairs? They sum to 180, so we're going to just say that they are supplementary. And if they're supplementary, then that means that we use this formula. And I am definitely going to make this one a tad bit easier. I'm going to make angle 2. I'm going to make it, let's see, 60 minus 5 is 55. No, 61 minus 5. Let's see. 4 goes into 64, right? So we'll make this one 69 degrees. Oh, shoot. I'm going to mess that up. Well, let's try it anyway. Okay, so the first angle is 4n plus 5, and we've done a couple of times where we had the parentheses. If it's positive, you don't even need them anymore. The other angle is 69 degrees. That equals 180. Well, 5 and 69 add up because they are on the same side of the equal sign. So that's just 4n plus, what is that, 74? 180 minus 74. Is that 106? 106, okay. So I'm going to get a decimal this time. I apologize, it happens sometimes, especially when I alter the question a little bit. So 4 goes into 10 twice, right? With 2 remaining. 4 goes into 26 6 times with 2 remaining. So this answer will be 26 and a half. And when you get decimals like 26 and a half, those can actually be problems that I would give you. I typically won't give you a long running decimal, but a 0.5, yeah, I can give you a 0.5. Okay. You guys okay seeing that? I've made the notes a little bit simpler than what they were initially, but I hope that helps you and doesn't hurt your progress. Okay? Okay, so I've done my best today to teach you guys on complementary angles, supplementary angles, adjacent angles. And the reason I told you about adjacent angles is so that you could understand the definition of linear pairs. All right, we talked on how the complementary angles add up to 90 degrees and the supplementary angles add up to 180 degrees. So you will want to use either one of these formulas when you approach that kind of question. All right, so there you go.